Good morning, everyone. Welcome to Science Class Online, where we'll continue learning just like we do back in the classroom, a little bit about science. You will see attached to this assignment your notes pages. These are the same pages that we use in our notebook that we'll end up putting into our notebook a little bit later on. I'd like for you to download the PDF file that you see attached for this lesson. And I want you to use markup as you're downloading this file and take your notes that way. You can either handwrite the notes, or I prefer that you try to type the notes in over the top of each of these missing blanks on your notes page. So you will be looking at notes page 99 and page 100 in this lesson. I'd like for you also to open up your science books to page 118, lesson 2 on the inner planets. Our vocabulary terms for lesson 2 is terrestrial planet and the greenhouse effect. So we're going to look at both of these words and try to determine what they mean. So let's get started. You should be looking at page 99 of your notes. And I want to talk just a little bit about what the terrestrial planets are. Earth and the other inner planets of Mercury and Venus and Mars are also called the terrestrial planets. Like Earth, the other terrestrial planets are made up of rock and metallic materials and have a solid outer layer. So the first note I'd like for you to make there on notes page 99 on lesson 2, the inner planets. Write this down, the planets made of rock. We found this on page 115 of our science book. Then I'd like for you to draw a model of the inner planets by drawing their orbits around this sun that you see on your notes page. I'd like for you to go ahead and label each inner planet. You do not have to do this in color, as the directions say. Just go ahead and label them. Put Mercury in closest to the sun. Make a circle for its orbital path. Go ahead and put Venus in, and it does not have to be on the same side as the sun as Mercury. Then put Earth in, and then Mars. And again, they do not have to be on the same side. They just need to be in the correct order. So Mercury, Venus, Earth, and Mars. You can pause this video for a few moments while you're going ahead and making that drawing. Now I'd like to continue on in our notes to the next section about describing the inner planets. And this again is found on page 115 of your science book. Describe the inner planets by completing this diagram. The inner planets are, this first box, also called the terrestrial planets. Like Earth, other terrestrial planets are made of rock and metallic materials. The 4 planets, the missing word, is closest to the sun. So for this first note in your notes for page 99, the inner planets are also called the terrestrial planets. And the second note, the inner planets are the 4 planets closest to the sun. Those are the 2 missing words. Let's move ahead and talk about planet Mercury. The inner planets are roughly similar in size, with Earth being about 2.5 times larger than Mercury. Here you can see actual images of the 4 inner planets, Mercury, Venus, Earth, and Mars. Notice that Mercury is the smallest. Venus is similar in size, just a little bit smaller than Earth. Earth is the largest, and then there is Mars. Notice that Venus is covered in clouds, and Earth has some clouds. Mercury and Mars do not contain any clouds. So let's talk about the planet Mercury. And at the bottom of your notes of page 99, you're going to write this down, that you found this on page 116 of your science book. We have in our notes organized facts about Mercury by completing this spider map. So let's start with the crust. The crust of Mercury, as you can see in this image, is thin and rocky. So write that down, thin and rocky crust. Very similar to our moon. For atmosphere, you're going to write no atmosphere, or you can just write the word none. There's no atmosphere at all, so write the word none. There's no clouds, there's no air, there's no atmosphere at all. So as meteors from outer space come in and they hit Mercury, they do not burn up the atmosphere. They will go all the way to the surface and they will form these craters that you see in this image. For diameter, this is your next circle. Diameter, you can see this on the screen. The diameter is 38.3% of Earth's diameter. So write down 38.3% of Earth's diameter. 38.3. Surface temperature. Now, this is not on the chart that you see in front of you, so you'll have to listen up. Surface temperature on the planet Mercury is negative 170 degrees Celsius. So put down negative 170 C to a positive 450 degrees Celsius. So negative 170 to positive 450. That's from night to day. So extremely cold nights and extremely hot days. Let's talk about the mass of Mercury. This is your next circle. The mass of Mercury, you can copy it right off the chart, is 5.5% of Earth's mass. 5.5%. The surface appearance, what does Mercury look like to you? Well, it is heavily cratered. So you can write down heavily cratered. So there's craters everywhere, very, very similar to our moon. The average distance from the sun, 0.39 AUs, 0.39 astronomical units. You can write AU. So it is closer to the sun than our planet. And for the core of Mercury, as you can see in this image, you can see that have a solid inner core, liquid outer core. But for the word core, I'd like for you to write that's made up of iron, I-R-O-N, iron, and nickel. Iron and nickel substance in the core. Now, like we've done in the past, I'm going to ask you to write some additional notes for each of these planets. And we're going to put the additional notes in the left-hand column over there where the word Mercury is. I found this on page 116. We're going to write down the rotation and revolution times of each planet. So for planet Mercury, you can copy it off the chart you see in front of you. Write the word rotation, and then next to the word rotation, put down 59 days. So planet Mercury spins much slower than Earth. One Mercury day is 59 Earth days long. That's almost 2 months long for a day. So you thought a day on school was long, go to Mercury. You have a very, very long day. You would come to school for a month and you go home and sleep for a month. Next note I'd like for you to write in the left-hand column is revolution. How long does it take for it to go around the sun? And then next to the word revolution, you write 88 days. 88 days is a year on Mercury. So you're having a birthday on Mercury every 88 days. Now we know that Mercury does not have any moons, so if you want to write that down in your last note, number of moons is equal to 0. No moons that we're aware of on the planet Mercury. So planet Mercury's surface has many craters because almost no erosion occurs. The craters and other surface features last for billions of years. There is a basin on Mercury called the Caloris Basin. It is about 1,550 kilometers across. It is one of the largest impact craters in the solar system. It was formed billions of years ago by the impact of an object about 100 kilometers in diameter. Mercury's gravity is not strong enough to hold an atmosphere. So Mercury's temperatures, again, I'll repeat this, are as high as 450 degrees Celsius on the side toward the sun and as low as negative 170 degrees on the side away from the sun. Like all the inner planets, Mercury has a core made of iron and nickel. So you should have had that in your notes for that circle. So that should complete page 99 of our notes. Let's continue on to page 100. And on page 100, we're going to do a comparison with Mercury and Venus. Compare and contrast the characteristics of Mercury and Venus. Write this down underneath the word Venus on the left-hand side. We found this on page 117 of our science book. So let's look at the Mercury box first. And just write down some bullet points. You'll notice the first one should be done for you. First bullet point, a little dot, says no atmosphere. So there's no atmosphere on Mercury. Go ahead and make a second bullet point. Put a little dot and write this down. It has a cratered surface. Cratered surface. So that's your second bullet point. Cratered surface. Your third bullet point would be this. Put a third dot. It is much smaller than planet Earth. Much smaller than Earth. And then the fourth and last bullet point that you have to get in that box on Mercury is that a day is shorter than a year. A day is shorter than a year. Very similar to what we have here on planet Earth. Our days are 24 hours. A year is 365 days. So let me repeat on Mercury. First bullet, no atmosphere. Second bullet, cratered surface. Third bullet, much smaller than Earth. Fourth bullet, a day shorter than a year. Let's go on to Venus now on the right-hand side. And we have Venus up on your screen. The first bullet is that it has a thick atmosphere. I think that one's done for you. Thick atmosphere. The second bullet is the surface of Venus is covered with lava flows. Surface covered with lava flows. There's lava everywhere on Venus. Many, many volcanoes. And a lot of lava. Surface covered with lava flows. The third bullet is very interesting. Make sure you write this down correctly. Here it is. A day is longer than a year. Yes, you heard me. A day is longer than a year. And we're going to write down what that is here in a moment. And then the last and fourth bullet for Mercury, or for Venus, for Venus, is it is almost the same size as Earth. Almost the same size as planet Earth. So let's repeat the bullets for the Venus box. Thick atmosphere, it's the first one. Second one, surface covered with lava flows. The third one, a day longer than a year. And the fourth one, almost the same size as Earth. That leaves us the middle box, which says the word both. And there will be 1, 2, 3, 4, 5, 6 bullets, so you need to write really small to get it in there. You may want to type these instead of trying to hand write these on markup on your iPad. see if you can make a text box and type these in. The first bullet on both is they are inner planets. I think that's done. The second bullet is no moons. There are no moons on Mercury. There are no moons surrounding Venus. The third bullet, both are closer to the sun than Earth. Closer to the sun than planet Earth. The fourth bullet, they both have rocky surfaces. They both have rocky surfaces. The next bullet, the fifth one, years are shorter than Earth. The years on both Mercury and Venus, the years are shorter than an Earth year. And the very last bullet is the days are much longer than Earth days. And the days are much longer than Earth days. So you should have the Mercury box filled in, the Venus box filled in, and the both box filled in. On the far left-hand side, I'd like for you to add a couple more notes over there where I found this on 117. Let's write down the word rotation, and you can see it up on your screen. Period of rotation for planet Venus is 244 days. A day on Venus is 244 Earth days long. Now, not only that, but Venus spins backwards, as we saw in the video back in class last week. So the sun will rise in the west and set in the east, and the day is 244 Earth days long. Write down the word revolution, and then write 225 days. Revolution, 225 days. So a year on Venus, listen to this, is 225 days. A day on Venus is 244 days. So yes, you're correct. Almost every day, in fact, you would celebrate your birthday on Venus because the days are so long, 244 Earth days long, and a year on Venus is 225 days. So Venus moves very, very slowly in its rotation time, and it gets around the sun pretty quickly in 225 days. Let's move on then to the next note on why Venus is hotter than Mercury. Explain that. You find the answer on 117, and here comes the answer up on your screen. And the answer is this. Venus's atmosphere traps energy. Therefore, the greenhouse effect greatly increases the planet's temperature. It's a runaway greenhouse. You'll notice in this image, you can see the clouds of Venus. There's no such thing as a clear day on Venus. It's always cloudy. And even though you think cloudy days would be cooler days, the clouds act as a gigantic blanket, all right, and they trap the heat of Venus. So, explain why Venus is hotter than Mercury? It's because the greenhouse effect has greatly increased the planet's temperature. Now, several years ago, our country, NASA, sent the Magellan orbiter to Venus, and it looked through the clouds with its radar and made many pictures of the surface of Venus. So we can see what it looks like in our book. And if you'll turn in your book to page 117, you actually see one of those images at the very, very top of the page. Now, Venus is covered in 97% carbon dioxide, so there's no oxygen there to breathe. And the pressure of Venus's dense atmosphere is 90 times greater than Earth's atmosphere. In other words, it would crush most spaceships that could go to the surface of Venus. The human body could not stand 90 times the pressure of our Earth's atmosphere on you. It would crush your bones, crush your muscles. Would not be a nice day. And to make things worse, The clouds are acidic. A thick layer of acid clouds covers Venus. So not a very nice place to visit. Let's go over again that the greenhouse effect occurs when a planet's atmosphere traps the solar energy and causes the surface temperature to increase. Because of its greenhouse effect, Venus is the hottest planet in the solar system, with an average temperature at the surface of about 460 degrees Celsius. All right, the last note that we're going to get into is about Earth, and we're going to start it today, and then we'll continue this tomorrow, continue our discussion of Earth, and then we'll go on to Mars. So the last note on page 100 of your notes is sort facts about Earth and Venus and place the number of each fact in the Venn diagram. You see at the bottom 2 circles, and there's an Earth circle, and there's a Venus circle, and then between the two, there is a both. So we're going to just write numbers down there. So let's start with number 1. Which planet has a greenhouse effect? And the answer to that is that they both do. So put a number 1 down in the very center section there, right underneath the word both. The second one has extremely high temperature. Well, that applies to Venus. So put a 2 underneath the word Venus in the Venus circle. Number 3, has water in its atmosphere. This would be planet Earth. We have water, we have clouds, we have rain in our atmosphere. Put a 3 underneath planet Earth. Number 4, a year is longer than its day. That would apply to planet Earth. Our year is longer than its day. So number 4 under Earth. A year is longer than its day. On Venus, it's the other way around. A day is longer than its year. So number 4 underneath Earth. Number 5, the atmosphere mostly carbon dioxide. We just said this a little bit ago. That is for Venus. So put a 5 underneath Venus. Number 6, rotates counterclockwise. That would be Venus. So put a 6 underneath Venus. And then number 7, rotates clockwise. That would be planet Earth. Number 8, classified as a terrestrial planet. That's both of them. So put an 8 underneath the word both. Number 9 is an inner planet. That's again, both of them. So put that under both, number 9. Number 10 has a moon. That's planet Earth. We have a moon. Venus does not. So put a 10 underneath Earth. Number 11, see if you can guess this one, has water on its surface. That's right. That's planet Earth. Number 11, planet Earth. And number 12, let's see if you can get this one right, can support life. Venus or Earth? Well, as of right now, it's only planet Earth. We don't think there's life on Venus. Several weeks ago, there was some discussion about life in the clouds of Venus, but we don't think that that's happening. Well, I hope you enjoyed our discussion. I'm not going to give you any homework today. We just thought we would have a video. No homework today. There will be some coming later on this week. Tomorrow, we will continue our discussion of the inner planets, and we'll talk about Earth and Mars. So I hope you enjoyed our discussion today and continue working very hard in class. And I will see you tomorrow. Good luck with what you're doing in each of our classes, and we'll see you in a couple weeks back at school. Take care, everyone.